Good morning, guys. Another video for you here on trigonometry, in particular calculating the area of a triangle. This is just an extra video from yesterday. I said, have a go at some of these questions and I'd put the answers below, but I've decided that when I start giving you questions like this, I'll actually do a quick video. The idea of this video isn't really to teach you how to do this, but it's kind of just to reinforce the idea. If I show you a few more examples just quickly, then you can go over them, you can check that your answers are correct. So if you haven't already tried these examples, give them a go. So you're just trying to calculate the area of these 6 triangles here, and you're going to be using the half AB sine C method, the sine rule, to calculate the areas of these triangles. So let's make a start. I'm just going to do all 6 of them quite quickly. So with this first one here, both of these lengths here are A and B, and the angle in between them is C. So the area for this one is simply a half 5 lots of 8 multiplied by sine 75. Okay, and we'll come back to that in a minute and we'll work it, we'll work them all out with the calculator in the end. This one here, the angle 125, so that's the angle C. A and B are the 2 lengths next to it. So the area for this will be 1/2 10 15 sine 125. This example here, again, it's the same thing. The angle C here is adjacent to these 2 lengths, so 6.8 lots of 7 divided by 2 sine 97. So it doesn't matter here if you divide this by 2 or times it by 1/2 like I did here, it makes no difference. This example here, okay, same thing. I'm not going to label a triangle this time. You can see here that we have an angle and 2 lengths are adjacent to it. So for this one we have a half, lots of 3.9, 2.5 and sine 34. Okay, this example here is the first one, which is an example where you have 2 lengths but you don't have the angle that connects them. So here you need to calculate this angle. Okay, well, how do we calculate the angle in a triangle? Well, if we have 2 angles, we can calculate the third by summing these together. So 80 plus 40 is 120, and then subtract that away from 180. So 180 subtract 120, and that is 60 degrees. So this angle here is 60 degrees. Okay, and then we do then the same thing that we did up here. It's a half 23 multiplied by 30 sine 60. And then the final example, this one here, same thing again. We don't have this angle, so what do we need to do? Well, we need to add 78 and 60. So add those together. Is 138, and then this angle here is 180 subtract 138, okay, which is 2 and 4, 42. Okay, so if this angle here is 42, that simply means then that the area of this triangle is a half 17 21 sine 42. So it's just a case then of putting these into a calculator. So I think the first couple of these questions I went through in the previous video. I've just included them here because it only takes a minute. So let's calculate the area of this one then. So 0.5 times 23 times 30 lots of sine 60, and we get a value of 298.8. and that's 1 decimal place. Okay, so hopefully the camera picks up the display here. I'm not sure how the lighting is, but hopefully the camera picks it up. If not, it's 298.8. So I'm not going to go through all of these on the calculator. There's no need to really. You just literally put in what I've written down here into the calculator and you will come up with values for these. So as long as you enter it correctly, you're absolutely fine. I'll do this one as well. So 0.5 times 3.9 times 2.5, lots of sine 34. No need for lots of brackets or breaking it down into steps, and that there is 2.7 to 1 decimal place. Just put it to 1 decimal place. And here I've just noticed here I made a mistake. I'm not sure why I put the degree sign there. There's no need for that. It's centimetres squared. And this one here is centimetres squared as well, because both measurements are in centimetres with both of these examples. So this example here, your final answer should be in millimetres squared. This one here would be centimetres squared. This one here would be metres squared. So hopefully that's helped you if you were maybe struggling with that, or hopefully this has confirmed your answers if you did okay. Now I'd like to bring your attention to these 2 examples here. Calculate the area of each parallelogram below. I'm not going to show you how to do this in this video. I'm going to ask that you attempt this yourself, and I will post another video on how to calculate these. There is an easy way of doing this, and there's a quite more let's say involved method. It's doable, but it's certainly not the easiest way of doing it. So there is a bit of a trick to this, but once you've seen it, you won't forget it. So have a go at these 2 examples here, and I will see you in the next video. In the meantime, please subscribe and comment down below if you'd like to see anything. As always, guys, if you see me make any errors or anything like that, please do make me aware of it as soon as you can. So like this mistake here, I don't I'm not really able to edit my videos and take lots of shots to make sure everything's perfect, but I do want to make sure that all of my videos are free from subject knowledge errors. Excuse me. I think it's quite important that when you're trying to learn something, you're not showing any mistakes. Otherwise, you can then think that those mistakes actually aren't mistakes. It's what you're supposed to do, and then you guys learn the wrong stuff, and I don't want to be responsible for that. So please, if you ever do see any mistakes, please don't be afraid to let me know. Like I say, my videos might not be the best quality, but I'm trying to get out as many as I can, and I'm hoping that they're all very high quality when it comes to subject knowledge, and I hope they're very effective in helping you all out. So thank you very much for watching, and I'll see you a little bit later on today.